Alright, so this is the problem I asked you to do as homework. And this is going to be the starting example of combustion. To remind you, combustion will always be, for this class anyway, at this time in your chemistry career, all the combustion reactions we're working with will have a hydrocarbon. Okay, it has hydrogen and carbon in it, so it's a hydrocarbon. And oxygen on the left side. All of these on the left side are reactants. Products are over here, these are reactants. So the reactants will always have a hydrocarbon and oxygen. Okay, now later on you'll have to predict the products, but predicting the products for combustion is really super simple because they're always the same, carbon dioxide and water. For right now I'm giving you the products, but eventually you'll have to do that. Okay? Alright, so to balance this equation then, we need to make an atom inventory. So we're going to write down each of the elements that are in the equation, and we got, here's our sneeze. Chew. Okay. Alright, so we're going to count now the elements. We've got our atoms. We've got 2 carbons here, 6 hydrogens here, 2 oxygens here. Over on this side we've got 1 carbon, we've got 2 hydrogens, and we have 2 oxygens here and 1 there for a total of 3 oxygens. So what we want to try to do is get the numbers to even out on both sides. We want to have an even number of each of these elements, or atoms. So we're always going to do oxygen last. This is always going to be balanced last, and this is always going to be balanced next to last. Okay? Alright, so we're going to start with our carbons then. We've got 2 carbons on the left side. To get 2 carbons on the right side, I can't change any of the formula. I can't put any subscripts in here. Once the formulas are balanced, we leave it alone. We only use coefficients to balance it. Okay? So that means I have 2 carbons. But now I've multiplied the number of oxygens by 2. So at the moment I have 2 times 2 is 4 oxygens plus 1 oxygen. This plus sign applies to this too, plus 1 oxygen. So I have a total of 5 oxygens. Okay? Now, you know, you got this tool here called a pen or a pencil. And a lot of students for some reason don't want to use that. I don't know why, but it's an important tool. And when you're doing some sort of complex, keeping up with numbers things, you want to write them down. See how I wrote them down over here to keep up with it? That's a really good technique. Write stuff down as you go. Then you know what you've done. You won't be lost as to what you're supposed to be doing. Okay? So now I have the carbons are balanced. We're going to save oxygen for last. So I want to balance the hydrogens next. I've got 6 on the left side and 2 on the right. In order to get 6 hydrogens here, I need a coefficient of 3. That'll give me 6 hydrogens, but it's going to change the number of oxygens. So I'm going to go here and use this neat little tool I've got here and write this down. 2 oxygens here times 2 gives me 4 oxygens there, plus 3 times 1 is 3, so I have 7 oxygens. I want to change this to 7. Well, now we've got everything balanced but the oxygens. And this is that situation I mentioned yesterday where we have an even number of oxygens on one side and an odd number of oxygens on the other. Now, how do we fix it when we got an even number on one side and an odd number on the other? Multiply everything by 2 except the coefficient in front of the oxygen. Okay? So that means this over here where I have an implied 1, that 1 gets multiplied by 2, I've got a 2 here now. And this 2 here in front of carbon dioxide, it gets multiplied by 2, so now that's going to be a 4. And this 3 gets multiplied by 2, so it's going to be a 6. I need to go back and recount everything now in the atom inventory. Okay? So now I've got 2 times 2 are 4 carbons. 2 times 6, I've got 12 hydrogens. the oxygen staying the same for the moment. 4 times 1 carbon gives me 4 carbons. Okay. I got 6 times 2 hydrogens. That's 12 hydrogens. Now we got to figure out our oxygens here. So I've got 4 times 2. That's 8. Plus 6 over here. 6 times 1 is 6. So I've got how many oxygens? 14. So we change the 7 to a 14. Well, now getting this to be 14 is fairly easy. I've got a subscript 2, so I need to multiply by some number that's going to multiply by 2 to give me that 14. 7. And that'll give me 14 oxygens. Okay? All right, so that's an example of combustion. So we're going to classify this then as a combustion reaction. Okay?
So when you have the uneven, you just go back and change some of the coefficients.
Well, when you have it, usually it applies to only oxygen because it works. I mean, it works for anything, but it comes up more often with oxygens than anything else. When you have a place where everything's balanced with the oxygen, and you've got an odd number of oxygens on one side and an even number on the other, you want to go through and multiply all the coefficients by 2. Except for the one that's in front of oxygen. And when I say oxygen, I mean the O2 itself. Yes? All right. Does that make sense to everybody? All right, so that's a good example of a combustion reaction. Let me review here a little bit with some other kinds of reactions, okay? So let's do a, I won't put this reaction down, let you see if you can help me figure it out, okay? Oh, I need to adjust my thing up there so it's not off the screen. I don't think I can get to it from here. Let's see. I'm trying to turn it a little bit. That's a little bit better. That's a little bit better. Yeah, I'll get up there on the ladder and do it later. Get it adjusted. Okay? Alright. So, what kind of a reaction is this going to be? Okay. Double replacement, she says. How do you know that? How can you tell it's double replacement? Yeah. Okay, you have to look at the formulas and figure out that there are two-part compounds here. So, and naming them can help you. It's not the absolute answer to the thing, but if you name this compound, you can see that's ammonium carbonate. Got a polyatomic ion here and a polyatomic ion there. So the polyatomic ions tend to stay together. Those are parts, 1 part and 2 part. So if we're going to label this as in that AB form, then that's A and B. This is magnesium sulfate. It's an ionic compound. And you've got 1 part is magnesium a metal, or the metal ion, and this sulfate ending. So that's a C and D part. Okay? And For a double replacement reaction, the reactants will always start with either ionic compounds or acids. In a double replacement reaction, the reactants will always start with either ionic compounds or acids. Okay? So if this is double replacement, then A needs to go, the front part of this, A, needs to go with the back part of this, which is D. And let's see if that happens. So we want to find this NH4, and there it is, that's the A part. It needs to go with this D part, which is SO4, and sure enough, it did. And in the front part of this, the C part, the magnesium, needs to go with the B part. Sure enough, there's C, and here is B. Okay? So the front part of this went with the back part of this other one over here, and the front part of this went with the back part of this one over here. And the front parts always stay front parts. Okay? So that is, in fact, double replacement. This is a double replacement reaction. Okay? Now we need to balance that reaction. What is the process we use for that? AI, or atom inventory. We have to atom inventory. So let's see, on this side I've got nitrogens, and I've got hydrogens, and I got carbons, got oxygens, got magnesiums, I've got sulfurs, and I've already written down oxygen, so I'll have to write it down a second time. Now we're going to make this little spreadsheet here, a little tiny piece of a spreadsheet. Okay. And we want the middle line to go right up under the arrow there. Because the idea here is that everything on this side of the equation stays on this side of the line, and everything on this side of the equation stays on this side of the line. Okay? Now we're ready to count. I have an N here, and I don't have a coefficient after it, so that's one N, but it's inside parentheses with a 2 outside. The 2 outside is multiplying everything inside by 2. So that's a 2 times the 1 nitrogen. I have 2 nitrogens. Okay? By the same process then, this 4 applies to the hydrogen, meaning I have 4 hydrogens, and the 2 outside means I'm multiplying everything inside, including the 4 hydrogens, so that means I need 8 hydrogens here. There's no coefficients or anything after the carbon, that means I have 1, and there are 3 oxygens here, but there are 4 more over here, for a total of 7 oxygens. 3 oxygens plus 4 is 7. And I have 1 magnesium and 1 sulfur. Okay? Over on the other side, here's that nitrogen with the 2 outside the parentheses, multiplying everything inside. So I've got 1 nitrogen times 2. I have 2 nitrogens. 4 hydrogens here times this 2 is 8 hydrogens. Okay, carbons, I've got 1 carbon. Oxygens, I have 4 plus 4 of them here plus 3 of them here for 7 oxygens. 1 magnesium and 1 sulfur. So this is already balanced. However, for me in this class and for you in this class, it's not balanced till you prove it, and you prove it with atom inventory. So regardless of whether the equation is balanced or not, you must have an atom inventory to prove it. Got it? So I'm from Missouri, you got to prove it. All right? Oh, I'm sorry, I'm from Missouri, you got to show me. Yep. There you go. Huh? Okay. So that's an example of a double replacement reaction then.